This is TID 21 and component ID 00. It's for the after catalyst oxygen sensor, the B1S2. It's going to compare the switching ratio. Now, CID 00 indicates we have a maximum limit. Now, you may also occasionally see an FF, meaning the test did not have time to complete. This is the right side sensor when dual O2 sensors are used for catalyst monitors. The PCM monitors the aftercat sensor voltage and compares the switching of fuel control sensors to the aftercat sensor switching. Now, the values aren't converted into measurement values, so use them as a relative indicator of operation. The typical data will be used to show you actual results. Here's some mode 6 data we captured. Remember, the monitor fails when the value is above the maximum limit. Now, in this particular case, we have 4 with a maximum limit of 200 on mode 21. We'll use scope patterns to verify any failures or look at this in more detail. Now, here's a scope pattern. The red pattern is the after catalyst signal. The green is fuel control. As you can see, there's not a lot of switching. At least the amplitude is smaller in the red trace. Now, we use the lab scopes again to help us direct us to a problem area. We're not always going to be able to identify the cause of a failure, although here it's going to be usually pointing us toward a bad catalyst. Let's see how that looks. Notice this red after catalyst signal. In this example of a failure, where the red is the aftercat signal, we have far too much switching. It's switching almost as frequently as the green. So this is one of the patterns. We've seen several different patterns, but we'll show you the whole thing when we go look at our lab scope patterns to verify mode 6 data we're looking at here. We're going to take a moment to talk about the pre-cat and after-cat oxygen sensor voltages. The red is the catalyst monitor. The green is the fuel control. Now, we need good fuel control in order to judge the cat monitor, and we're going to talk about that. So let's stop this and examine exactly what we're looking at here. If you'll notice, the red trace is almost steady. Very good. The green trace is going from rich to lean. Now, rich is the high voltage. The lean is the low voltage. We have good activity here. We must have near normal O2 sensor in the front before we judge the rear. Why? Let's do a snap accelerate and we'll show you why. When we do a snap accelerate, both sensors go full rich. The fuel control is full rich and the aftercat goes full rich, almost at the same time. Notice we have some clipping. JTEC can go over 1 volt when the oxygen sensor is a little cool. Fuel control drops lean right here. We have a significant time delay before the aftercat drops lean. So we have quite a bit to see here. We want to watch the difference in fuel control and aftercat to see how active the cat is. We cannot stress too much that the cat must be fully warmed up before this test. Don't expect a cold cat to give you a good pattern. That's one of the fallacies. But also remember, don't overanalyze this. The PCM is going to detect the problem. Use this type of pattern to verify mode 6 information. You don't have to figure it all by yourself. Mode 6 is already going to be telling you to look at this.